Welcome to this session. This session, we are going to discuss about the second type of integration technique. The name of the technique is integration by substitution. So this is the second one. The first one we discussed about power rule. So let's see how we work out integration by substitution method. So if and the derivative of a function f of x exists, so remember this capital F of x is what we use to denote as capital F of x is then the derivative of the function small f of x. So if you differentiate then derivative and you get the function you have, then the integral of the function f of u can be obtained by replacing f with u of x, with this a substitution u, and then multiply by the derivative of that replacement u, and then you get your value of the and the derivative as f of u of x plus c. Or we can frame it in a different way by saying if u is g of x is a differentiable function of x whose range is on an interval I, and f is a continuous function, then the substitution method works by saying that you replace the function u of x into the function f, and then differentiate that function with respect to x, and then this integral can as well be written as integral of f of u du. Simply what's happening here to make things or to make more sense to the method is that you'll be given an integrand where power rule cannot be used directly. So what you have to do, you have to choose or to fix some part of the integrand, let it to be u, in such a way that now once we have fixed that place, then the remaining or the resulting integral will be easier to integrate by, say, method of power rule or other methods that we are going to learn. Once you have that one, then you change the structure of your integrand to be purely in terms of u, and then you carry out integration with this new variable u. And once you have gotten your answer in terms of u, then replace back in terms of the original variable that was given in the integrand. So let me explain that one more fully with some examples. So appetizers. So evaluate the following. So the first one, A, integral of x plus 2 raised power 5 dx. Let's start with that appetizer. X plus 2 raised power 5. I know this we can as well expand by binomial and integrate by power rule, but then I don't want us to pick that route because we're going to take a lot of time. So what we do here, in this we would say solution. You let all this bracket to be u, so let u to be x plus 2. So which means then our integral will be integral of u raised power 5. And then remember now, once you say let u to be this one, then this means that du is the same as dx, or du dx is the same as 1, and then you multiply through by dx. So du equals to dx. So where there is dx in this integral, you replace by du. So it'll be integral of u raised to power 5 du. And by power rule, this will be u power 5 plus 1 divided by 5 plus 1, then plus c, which will give us u power 6 over 6 plus c. So which means that the original integral of x plus 2 raised to power 5 dx is the same as, now replace u by what it was initially, x plus 2, and then you raise to power 6, divide by 6, and then plus constant c. So that will be the solution to that problem. B, integral of square root of 4x minus 1 dx. Now, for us to evaluate this one, we use power rule. We use substitution method, and then power rule will help us now to do the integration after substitution. So solution. So integral of square root of 4x minus 1 dx is the same thing as writing the integral of 4x minus 1. Now square root is the same as raised power half. Now once you write your integral in this form, you let the bracket to be u. So let u to be 4x minus 1, which means du will be 4 dx, or du dx is the same as 4, then you multiply by dx, you get 4 dx. So this implies that the integral of 4x minus 1 raised power a half dx will be the same as the integral of u raised power half, and then where there's the x, you replace by. So if du is the same as 4 dx, then you should be able to see that dx alone will be du over 4. You divide through by 4. So this will be du over 4. And this a quarter, you factor it out. So we'll have 1 over 4 integral u raised power half, and then du. So this new integral in terms of variable u can be evaluated by power rule. So say a quarter times u raised power half plus 1 divided by a half plus 1, then you add constant c. So a half plus 1 is 3 over 2. And then this would be 1 over 4 times, now 3 over 2 reciprocal is 2 over 3, u raised power 3 over 2 plus c, and then this 2, 1, 2 into 4, 2. So we'll have 2 times 3 is 6, so 1 over 6, u raised power 3 over 2 plus c. But remember, u was not in the question, so you replace back in terms of x. So therefore, the integral of square root of 4x minus 1 dx will be 1 over 6 into 4x minus 1 raised power 3 over 2, and then plus c. So that's what that problem simplifies to. C, integral of cos of 7x plus 5. Now what we do, we fix this bracket. So we say let u to be 7x plus 5. So which means du will be 7 dx. And dx alone will be, you divide through by 7, so du over 7. So therefore, the integral of cosine of 7x plus 5 dx will be, because we have fixed this to be u, dx will replace by du over 7. And the scalar 1 over 7, you factor it out. So 1 over 7 integral cos of u du. And from our earlier discussion, the integration of a cos function is a sine function. So this will give us 1 over 7 sine of u, then plus a constant of integration c. So therefore, integral of cosine of 7x plus 5 dx is 1 over 7 sine u is 7x plus 5, then plus the constant of integration c. So that is the solution to that given problem. C, our next problem D, we have integral x squared sine of x cubed dx. So remember here, in this integrand, there is x squared part and x cubed part. So one choice of u can be x squared, another one can be x cubed, but you have to be very careful in such a way that what you are choosing to be u should allow you to eliminate all the x's in the integrand. You see, if you choose u to be x squared, then when you differentiate, you get 2x. So this x power 3 will still be in the problem. So it will still give us a problem. But if you choose u to be x power 3, when you differentiate it, you'll get an x squared, which can cross with this other x squared. So the best choice for you in this problem is x power 3, not x power 2. Because when you choose x power 3, after doing the transformation, this x squared will cancel out. This is how it will. So you say, let u to be x power 3. So which means du will be 3x squared dx. So which means the x will be du over 3x squared. Simply divide through by 3x squared. So this means now the integrand x squared, we have sine. Now I have already fixed this one to be u. Then I multiply by dx is du over 3x squared. You see, by doing that, x squared and x squared cancels out. So this and this cancels out. So that this integral will be sine u times du over 3. Now the problem now is purely in the new variable u. Factor this a third outside the integration sign. So this is the same as a third integral of sine of u du. And from our earlier discussion, the integration of a sine function is a negative cos. So this is negative a third cosine of u, then plus c. But remember, u is our own equation, so don't leave your answer in terms of u. So the integral of x squared sine of x cubed dx is negative a third cosine of, so where there's u, you put x power 3, and then plus c. So this is the solution to that given problem. And then lastly, E, integral of 1 over cos squared 2x dx. So here, note that 1 over cos squared 2x is the same as sec squared 2x. Remember that 1 over cos theta is the same as sec theta. So therefore, the integral of 1 over cos squared 2x dx is nothing but the integral of sec squared 2x dx, which means that we can fix this part of 2x. So we let u to be 2x, which tells us that du is 2 dx, from which dx we divide through by 2 will be du over 2. This means that the integral sec squared 2x dx will be the integral of sec squared u times du over 2. Factor out the half. So sec squared u du, and a function whose derivative is sec squared is a tan function. So this will be a half tan of u plus c, and therefore the integral of 1 over cos squared 2x dx is a half tan of 2x and then plus c. So that will be the solution to that given problem. More examples will be given in the next class. Thank you.